strong.
Yeah, hello friends. I'm Alok Mishra, your mathematics tutor at AcadPrime. I just welcome you all, both Siddharth and Swam, to the AcadPrime here. I think you both will be fine. Is it? Hello, Siddharth. How are you?
I'm fine.
Okay, and
Hello.
Swam, what about you? Okay, I think he has some sort of network issue. Okay, so just today will be having here for the demonstration of your subject, and today I'm going to check you one of the very interesting and important chapter of your subject. Okay, so let's have a look over the subject or the chapter that we are going to discuss here. Okay, I'm just sharing my screen with you. Hello,
Hello.
hello, hello,
Yes.
Hello.
sir. Yeah. It's fine. Okay, I'm just sharing my screen with all of you, and I will discuss over there. Okay, is the screen visible to all of you? Is it?
Yes.
Okay. So
Yes,
today
sir.
I'm just conducting a demo session here, and in this demo session I will be discussing a chapter of yours that I have already told that that's a very interesting one, and you already seen my profile here on the screen. And let's move towards your the session, and here we are going to discuss the exponent and the powers. I think you already have aware about this, but I will let you know in the deep for all these things. I'm just going to provide you the deep knowledge for this also. Okay, the first of all we will discuss what do you mean by power. And power is just an expression that represents repeated multiplication of the same factor, that is called the power. Suppose if you are writing 3, just for an example, I am writing here 3 cross 3 cross 3, and like that I have written it for the 3 times. And in the sorted form, if you just represent it in the form of the power, you can just write 3 raised to the power 4. That means that 3 is here represented multiplied for the 4 times, then we can just write it as 3 raised to the power. Here this 3 is called the base, this is called the base, and this 4 is called the power or the exponent. Okay, this will be called as a exponent, as already I have just given here in the diagram also. This is called the exponent and this is called the base here. Okay, so this is the meaning of your exponent and power here. Next, I'll be discussing here the one more concept with that means what are the things that we are going to discuss with the power with negative exponents. Suppose we have exponent as the negative one, like the first one as we have discussed here, 10 raised to the power 2. That means 10 is multiplied for the 2 times, that is 10 into 10, and that should be equals to 100. And next we have multiplied this here we have 10 raised to the power 1, and this would be equals to 10. How this 10 comes out? Here we have to discuss how this 10 comes out. Earlier you have seen we have 10 raised to the power 2. Okay, this 10 raised to the power 2 is equals to 100. If we have to just decrease its power to 1, that means if we just write 10 raised to 1, that means we are just dividing it as 10 raised to the power 2 divided by 10 raised to the power 1. Is it?
Yes.
Yeah.
Yes,
Is
sir.
there any doubt in this? Okay, so we can just write it like that, 10 raised to the power 2 divided by 10 raised to the power 1, and on cancelling out we just get 10 raised to the power 1. And I will just discuss this rule further in this slide also. So here we are just continuing that pattern, and come to a pattern where we are getting 10 raised to the power minus 1. Okay, so 10 raised to the power minus 1 seems means that it should be written as 1 divided by 10. Is it? Whenever there is a negative power, we just write it as 1 divided by that particular number. Suppose if you have been given that you just write 5 raised to the power minus 1, this means that this can be written as 1 upon 5. Is it? Similarly, Siddharth and Swam,
Yes.
are you getting it?
Yes.
Okay. The
Yes,
next
sir.
one I have been given here is that 10 raised to the power minus 2. Okay. So whenever I have already told you what is the meaning of minus. So it is written as 10 raised to the power minus 2. It should be, it can be written as 1 divided by 10 raised to the power 2. Okay. And whenever we just make the make this exponents, either we should go on to the numerator side or the denominator side, its sign will change. Suppose it has been given like this, that 10 raised to the power minus 2 divided by 1, this can be written as 1 divided by 10 raised to the power 2. And if this will be your question, suppose if I give this as a question and you have to write like this, then in that fashion you can just write it as 10 raised to the power minus 2. That means ki here this denominator goes up to become a numerator, है ना, this denominator goes up to become a numerator. So whenever we just exchange denominator and numerator, the sign of the power will also change. Okay, is there any doubt?
No, sir.
Okay,
Oh,
thank you. Okay, so moving forward, we have some laws of the exponents, and we need to follow all those rules for solving the problems of this chapter. The first law that we have is that we have learned that for any non-zero integer a, suppose we have been given two integers as a raised to the power m cross a raised to the power n. Okay, here we are saying that the base of both are same. Okay, as I have already told about the base and the exponents, and here we are saying that the base is same for both. Okay, so just conclude a rule here is that if the base is same, if the base is same, then its power will be added together. Okay, if the base of both the non-zero integers are same, then we just add its powers together. Okay, just see the first one we have been given here is that if we are having given 2 raised to the power minus 3, we can just write it as 1 divided by 2 raised to the power 3. And if it is given 2 raised to the power minus 2, we just write it as 1 divided by 2 raised to the power 2. Okay, this follows the rule. This is a general rule. I am just generalized this rule, and generalized in what manner? That means if it is given as a raised to the power minus m, that can be written as 1 1 divided by a raised to the power m. Okay, next, just take another example. We have taken the example as minus 3 raised to the power minus 4 and minus 3 raised to the power minus 3. As already I have told here that if the base of both are same, है ना? If the base is same, then power will be just get added, है ना? If the base is same, then power gets added. Here we see that the base is minus 3 for both the cases. Okay, and this is in multiplication. Base is same in both the cases. We can just write it as minus 3, and its power will get added together. Okay, we will get minus 3 raised to the power minus 4 minus 3, and that should be equals to minus 3 raised to the power minus 7. Okay, is it fine?
Yes, sir.
Okay, whenever you have any doubt, you just ask me without any hesitation. Okay, now we have some more laws of the exponents, and the first law here I have mentioned is that if you have been given as a raised to the power m divided by a raised to the power n, already I have told you that whenever we just exchange in between the numerator and the denominator, its sign will get changed. Suppose it has been given as a raised to the power m divided by a raised to the power n. Now it can be written as a raised to the power m into a raised to the power minus n, because we have changed it from denominator to the numerator. Now we just apply the first law that we have already discussed, is that if the base of both are same, if the bases are the same for both the integers, then we could just add up its power, है ना? If the base is same, we just add its power, then it should be equals to a raised to the power m minus n. Okay, so in simple manner we can directly use this relation as whenever it has been given that a raised to the power m divided by a raised to the power n, you can just directly use this as a raised to the power m minus n. Okay, is this a law clear to all of you?
Yes.
Okay,
Yes,
now
sir.
come to the next one. It has been given that a raised to the power m, okay, and a whole to the power n, okay, and whole raised to the power n. Then we just write it as a raised to the power m n. Suppose we are just taking an example. It has been given as 2 raised to the power 2 and whole raised to the power 3. Now it can be. Can any one of you tell me
64.
that? Yeah.
64.
No 64. You just tell me as 2 raised to the power m into n. That means ki 2 into 3, and that should be equals to 2 raised to the power 6, and that should be equals to what? 64. Okay.
64.
The next law is that if it is a raised to the power m and b raised to the power m, that means ki here your bases are different in both. है ना?
Yes.
The base is different in both the situation. Now we just multiply the bases, and the power will be given there. Just take an example over here. Yeah, I'm taking an example. It's 2 raised to the power 2 into 3 raised to the power 2. That means we can just write it as 2 into 3 raised to the power 2. Okay, but we will get from here 2 into 3,
Six.
that means 6
6 raised to the power 2.
power 2, that means it is equals to 36.
36.
Okay, now come to the next one. I'm just placing it. Okay, now come to the next. It is a raised to the power m and b raised to the divided by b raised to the power m. Now we can just combine the both and just write it as a divided by b whole raised to the power m. And if any number, any integer, if its power is given as 0 and its value will be equals to 1, that means whatever be it's given here, that example, as for example, if it is given as 2 raised to the power 0, that should be equals to 1. 5 raised to the power, that should be equals to 1. 100 raised to the power, anything raised to the power 0 should be equals to 1.
I have a
Okay,
1.
question.
yeah, just tell me.
It's about the fourth rule, where a is raised to the power of m over b is raised to the power of m.
Yeah,
How can it be a over b to the power of m? How do you get a over b to the power of m?
okay, just take an example. I'm just taking an example over here. Suppose it has been given that just take an example. It has been given that ki 8 divided by 9. Okay, not you just consider some 8 divided by 27. Suppose it has been given here. Okay, and if we just see, can we write 8 as 2 raised to the power 3?
Yes.
And
And
27 can be
27
written
as 3
as
to the power 3.
3 raised to the power 3. Okay,
Yeah.
we just take it together and we can write it as 2 by 3 whole raised to the power 3. Okay, this means this power can be applied over 2 also and 3 also. Okay, this
Okay.
bracket means this power can be applied to both. Okay,
Okay.
okay, now come to the next one. And next I have taken an example for all of you, and can you solve me quickly? Can you solve
Yes.
quickly?
Yes.
I just want you to solve it quickly and give me the answer. I'm just giving you a few seconds for this. Valli. Can you tell me which law can be applicable to this? Yeah, be fast. Be fast. I'm just waiting for your answer.
M equals to minus 3. Okay, that.
Okay, just match your answer. I'm just solving for you. Here it has been given that minus 3 raised to the power m plus 1 and plus minus 3 raised to the power 5. Okay, this would be equals to minus 3 raised to the power 7. As already I have told you that if the bases are same, then power will be added together. Now it should be a minus 3 m plus 1 plus 5, and this should be minus 3 raised to the power 7. Just write down one more law here. That means if it is given as a raised to the power m equals to a raised to the power n, in that situation, in this case we will be having m equals to n. Okay, so this situation arises here. We are saying that key on the left hand side of the equals to it, its base is minus 3, and on the right hand side it is also minus 3 as the base. Then if the base are same, then its power will be equal. Okay, this means we can have m plus 1 plus 5, that should be equals to 7, right? And
Yes, sir.
plus 6 should be equals to 7. Now we can solve this linear equation very easily. You
Yes,
have already studied about this linear equation, and this m
yes,
should
sir.
be equals to 7 minus 6, and that is equals to 1. Okay, so value
Yes,
of this means the value of your m is equals to 1. Can we have one more example? Have you understood this?
yes, sir.
Yes.
Okay, let's have one more example. We have been given the first question as we have to simplify this one. Okay, I'm just use the property of the exponents and the power to solve this. Okay, I'm just taking the first question here. The first question is what? It has been given as a curly bracket, that is 1 by 3 divided raised to the power minus of 2 minus 1 by 2 raised to the power minus 3, and bracket is closed, and then we have to divide 1 by 4 raised to the power minus 2. Okay, now we first of all we just try to solve this brackets, whatever given in this bracket we just solve it. For the first, it can be written as 1 raised to the power minus 2, and this 3 raised to the power minus 2.
Yes,
Okay,
minus 2.
minus 1 raised to the power minus 2 and 2 raised to the power minus 2. Okay, that's fine. Divide by
Yes,
1 by 4 raised to the power minus 2. Okay, now this can be equals to uh, this can be this can be equals to 1 raised to power anything should be equals to 1. Okay, and what is the value of this 3 raised to the power minus 2? Can we write it as 1 upon 3 square? Is it?
yes,
Okay, minus 1 divided by 1 upon 2
1.
raised to the power
Yes,
3. Okay, and we just close this bracket, and we just divide it, and this can be 1 upon 4 raised to the power minus 2, and this raised to the power minus 2. Now, this first one, 1 divided by 1 upon 32, can be written as 32 minus, oh, sorry, no, sorry, it's not 32, it's a power, and 1 upon 1, 3 square is your 9. Okay, minus 1 upon 1 by 8. Okay, and this could be 1 upon 1 divided by 4 square, right? Any doubt over here?
no, sir.
Now, this can be written as 9 minus 8 divided by 1 upon 1 by 16. Okay, now solve this bracket. 9 minus 1 8 and 8 is equals to 1. 9 minus 8 is equals to 1, and this is divide what this could be written as 16. Okay, this could be written as 16, and your answer will be what? 1 divided by 16.
16.
Is it?
Yes, sir.
Siddharth, have you got this answer?
Yes.
Yeah, actually I have explained all the things, uh, taking all the parts all together, and we'll get your answer here. Okay, just I'm having the example second. I'm just taking the second example here. Second example I'm just taking here. The question is 5 upon 8, that is raised to the power minus 7, into 8 upon 5 raised to the power minus 5. Okay, this can be written as 1 divided by 5 upon 8
To the
raised to the
power
power
7.
7, into
Okay.
1 upon 8 by 5 raised to the power 5.
5.
Now, this can be written as 8 divided by 5 raised to the power 7, into this can be 5 by 8 raised to the power 5. Now we just split all, then it can be 8 raised to the power 7 divided by 5 raised to the power 7, into 5 raised to the power 5 and 8 raised to the power 5, right? We just cancel out the things that are same. That means we can write it as 8 raised to the power 7 into 5 raised to the power 5. Since we are following the exponents and the powers, so we just try to solve according to the law. Okay, this 5 raised to the power 7 that has been in denominator, it can be written as 5 raised to the power minus 7. Okay, and this 8 raised to the power 5 can be written as 8 raised to the power minus of 5. Now we are getting here is that 8 raised to the power 7 and 8 raised to the power minus 5 is there. That means the base is same in both. Then we can just write it as, we just add up this power. That means ki 8 raised to the power 7 minus
64.
5, right? And we can also write it as 5 raised to the power 5 minus 7. Is it fine?
Yes, sir.
Okay, I'm just erasing this side. Okay, and this can be written as 8 raised to the power 2 into 5 raised to the power minus 2. Okay, then we can write it as 8 raised to the power 2 divided by 5 raised to the power 2, and this can be written as 64 divided by 25.
25.
This will be your answer. I think this will be clear to you.
Yes, sir.
Siddharth, is it clear?
Yeah, it is clear.
Yeah, that's I think that's end of our session and demonstration. And one thing that I want to ask you, yeah, how do you feel, how much percentage that you gain from this class?
100.
Yeah, you get
Yes,
you grasp all the things.
yes, sir. Good.
Yeah, I think if you also even if you grasp 80% of the things, and you know the mathematics is the thing that you need to have a practice. More and more practice can make you better in mathematics. Okay, so once you learn from the AcadPrime, and AcadPrime is already you've seen that, okay, this is providing a very good platform, and also the teacher and awesome teacher will are also there on the AcadPrime. That will they make you learn all the things from basic to the advanced level. Okay. So just try to be there, and we will there to help you all in every manner and make you a perfect in your classes. Okay. Thank you to all of you for joining the session. See you all in the next session over there. Okay. Thank you.
Goodbye.
Thank you. Yeah. Bye bye.
Goodbye.
Be strong.